Okay, so we're looking at disproportionation. Now, really what we're going to do is just introduce the concept and look at a better way to solve these questions once we start looking at oxidation numbers. So just for a definition for now and kind of being able to identify it, is disproportionation is a reaction in which a species is both oxidized and reduced. And we haven't really looked at any of these questions yet because solving them using half reactions doesn't really get us to where we want, or it's not a very easy method to find it out. So then the question here that it says, will a solution of iron 2 ions be stable, or will it undergo disproportion to give iron and iron 3 ions? So, you know, if I put, like, I don't know, iron nitrate in a solution, is this going to break down into solid iron and iron 3 ions, or is it just going to stay as iron 2 ions in solution? Because iron is part of those two compounds, like that, what is it, feel, hot, creamy, whatever, I can't spell, I don't know what I'm doing. Anyways. There we go. Okay. Iron is one of those, so that's what they're asking me, and so what I need to do is go look at my table and see where those iron 2 ions are. Well, the iron 2 ions in terms of a reducing agent are like, I don't know, 10th from the top-ish, so Fe2+, and this is when it's a Ra. When it's an OA, I gotta go find when it's an OA as well, and when it's an OA, it's down at the, like, kind of towards the middle bottom of the page, so it's down here when it's an oxidizing agent. So, is this solution that includes iron 2 ions going to be stable or not stable? What do they mean by stable? What do they mean by stable? Yeah, is it going to react? Will this react? Why not? Yeah, right. The OA is below the RA, so this is not going to react. So that's a stable solution. If it did react, it would undergo this disproportionation where I would have some of the ions being reduced and some of them being oxidized. So we're going to look at balancing redox reactions today. This should be a review from yesterday here, first of all. Do we need to go through another question maybe that was like on the quiz yet?
Wouldn't that, I can't remember, would it be stable though? Because it wouldn't react? Would that create an
Yeah, no reaction, so it's stable. Yeah. So still this is predicting redox, so this is like a question that was on the quiz. Do you guys think we need to go through that again? So like half the class seemed okay, half the class really didn't do good on the quiz. So it's up to you guys. What do you want to do? Do we need to go through this? Oh, this is a disproportionation question anyway, so that's fine, we'll go through it. Will a solution of chromium 2 chloride be stable? Predict the redox reaction and its spontaneity. So tell me whether or not you think that will be stable. Take a second to try that out. In this solution, what you would have is chromium, 2 plus aqueous ions and chlorine negative aqueous ions. Now, chlorine is not part of my ones that can be disproportionate, so I wouldn't even be considering that. I'm just looking at my chromium one. So if I go on here, chromium Cr2 plus aqueous, I found it as an Ra, so I'm going to go also look for it as an OA, and it is actually below Cr2 plus aqueous when it's an OA. So is this going to react? So no reaction, therefore it would be stable. I'm just looking on my table, right? I'm looking for my chromium 2 plus ions. They're right here, and the other one is below it. I'm just looking for the Cr2 plus ions when they're both on the OA and the Ra sides. Because the Cl isn't, like, well, chlorine doesn't really react anyways, but it is on there. But they're just asking me if this chromium ion is going to undergo disproportionation, is what they're asking me.
So then you can only really do that with the ones that don't.
Yes. Yeah. And the questions when we look at like disproportionation will become a lot easier once we do oxidation numbers. So, but here's a basic example. So, which of the following equations, and this is from an old diploma exam, represent a disproportion reaction? A, B, C, or D? Anybody know which one? Should look at it and it should be like super obvious. Anybody know which one?
Yeah, see.
Why C? Double thing. What do you mean by a double thing? Okay, you're saying because of this? H2O liquid as well. Okay. Water is always there, right? Technically, water's hanging out in here somewhere, but they're not showing it. So this one for a disproportionation, and again, it makes more sense when we look at oxidation numbers, but generally a disproportionation has an element that has broken into two things in the products. So that's why that one's a disproportionation. Nothing else has, nitrogen doesn't break into multiple things. Hydrogen, oxygen, right? They're all the same. All right, just a review question. So during cellular respiration, the oxidizing agent is what? Oxidation. That's not what I want. Alright, so this is, let's do a quick review question before we look at what we're going to do today. So this is similar to the quiz. So potassium permanganate is slowly poured into acidified iron 2 sulfate solution. Does a redox reaction occur, and if it does, what is the reaction? So I'm just going to go through this. Potassium permanganate, right? As soon as you see something and it's an ionic compound, well, and it says it's slowly poured, so obviously it's in an aqueous solution, right? But as soon as you see something like in terms of an ionic compound, you should realize that that is an ion, not solid potassium. And that's what a lot of people are doing on the quiz, which is a mistake. So potassium and then permanganate, NO4 negative aqueous, is slowly poured into an acidified. As soon as I see the word acidified, I'm just going to write down that I include hydrogen ions. Iron 2, so Fe2 plus aqueous ions, because this is ionic and it's a solution. And sulfate SO4 2 negative aqueous and water. And then I have to go designate which one is an OA and which one is an RA. Excuse me, sorry. According to my half reaction tables. Well, I know iron and water are both have possibilities of being OAs and RAs. Then when I look at this, I look at this and I say, well, potassium, when it's an ion, if potassium is an ion, it has to be on the left side of the table, so it has to be an OA. And because it's doesn't have the capability of performing multiple ions, it's only going to be an OA. Permanganate, now permanganate doesn't exist by itself on this table, but at the very, very top, if it reacts with hydrogen ions, it's a super strong oxidizing agent. And if I look here, I look at the two equations above this, which are fluorine and lead 2 oxide. I don't have any of that in here. So I know for sure this has got to be my reaction for my strong oxidizing agent. Now I'm just trying to figure out which one could be my reducing agent. I've already looked at iron. Sulfates and water can come together to give me an oxidizing agent, but that doesn't really give me any information that will help me with this question. And so I only have two possible reducing agents here, which are water and iron. And if I go look for my water half reaction and my iron 2 ions half reaction on the right side of the table, the iron 2 ions are lower in terms of the reducing agent than the water. So then I would just write out my half reactions just based off of this table. So magnesium NO4 negative aqueous plus 8 hydrogens aqueous plus 5 electrons is producing magnesium 2 plus ions aqueous and 4 water. So that is my oxidizing agent half reaction. And the half reaction for iron 2 ions is Fe2 plus aqueous is breaking into, is becoming iron 3 aqueous and 1 electron. So to write the net reaction here, what do I need to do? Right, I need to ensure the same amount of electrons are getting transferred from my from my Ra to my OA. So I would multiply this guy by 5. And so this would be 5, this would be 5, this would be 5. And the electrons cancel out, and nothing else in terms of the products and reactants can be simplified. So my final reaction would be 5 iron 2 plus aqueous. React with MnO4 negative aqueous. 8 hydrogens aqueous. What did I mess up on that? Okay, Fe3 plus aqueous. Mn2 plus aqueous. And 4 waters. And so that was really similar to that quiz.
H2O is always written as liquid, right?
Yes, yeah. Nothing. I'm just going over a review from yesterday.